The episode of the show where the assembly line at the candy factory goes too fast, and Lucy and Ethel start eating the candy to keep up. He uses this to try and explain to us how too much cholesterol is being stored in the lysosomes of cells, and the lysosomes can't store all the excess cholesterol, and that causes problems for the cell. So check with Dr. Ori about I Love Lucy show. He knows all about it. He will be our first speaker. The next speaker will be Dr. Porter. Dr. Denny Porter is the Senior Investigator and Acting Clinical Director at the Eunice Kennedy Shriver National Institute of Child Health and Human Development at the National Institute of Health in Bethesda, Maryland. Dr. Porter earned a combined MD PhD degree from Washington University in St. Louis and trained in both pediatrics and clinical genetics at St. Louis Children's Hospital. His main interest is in understanding the pathophysiological processes that underlie genetic disorders. His goal is to define clinical or biochemical aspects of Niemann-Pick type C that could be used as an outcome measure in a future therapeutic trial. And an interesting story about Dr. Porter is he has an interesting story about a hawk attack that attacked him in Tucson, Arizona at the Parsigan meeting. You can ask him about how he fought off the hawk, and neither rain, snow, or hawk attack will keep Dr. Porter from attending the Niemann-Pick disease meeting. And now my good friend Ronnie Bush is going to introduce Dr. Laura Liscombe.
Good morning. I'm Dr. Liscombe, PhD, is a professor of physiology at Tufts University, a School of Medicine in Boston. She received her PhD in biological sciences at Columbia University, New York, after completing her postdoctorate training in the Department of Microbiology or Molecular Genetics at Southwestern Medical School in Dallas, Texas. She joined the Tufts faculty in 1985 and began to work on Niemann-Pick type C in 1987. Dr. Liscombe studies the effects of different lipid disorders on intercellular cholesterol transport. Her lab has recently developed a mouse model to study the MPC pathogenesis. The lab's goal is to determine the mechanism by which lysosomal, sorry, I'm a little bit nervous. Okay, lysosomal cholesterol storage leads to neurodegeneration and liver disease. Now, Karen had asked me to introduce Dr. Liscombe because I had both attended and worked at Tufts University. So Karen had called me, and actually me and Karen have been friends since high school. And so Karen had called me after her son Ty was diagnosed with the disease and asked me if I knew Dr. Liscombe. You know, and when you think about it, at Tufts University, there's about 9,000 people who both work and go to school there. So the chances of me and Dr. Liscombe knowing each other are pretty huge. And so Karen was quite surprised when I said, oh my gosh, yes, I know her. I worked in the same department. And so it's wonderful that I was able to connect the two. And and Karen was able to call her the next day and to start to get information about the disease. So it's just a wonderful connection. Thank you.
I will start passing out those reports, and Dr. Ori will start to give his presentation.
Good morning. I want to thank Karen and Ronnie for the nice introductions. The goal this morning is really to give you an update in terms of where we are with some of the MPC research. And we have with us today myself as the chair of the SAB, but we also have Denny Porter and Laura Liscombe that will present really just the cutting edge research that's being done both at the bench and clinically in the MPC disease. We will probably have sufficient time, that I think we probably will have sufficient time at the end of each talk to take questions, but we will also have a panel discussion for both the NPA and MPC groups to follow this session this morning. So if you don't have questions that are ready at the end of the talks, just write them down and feel free to ask us during the panel discussion. Okay. With that, I'll begin with sort of the introductory topic, which is really understanding what are the current strategies for treating NPC disease and also challenges for developing new therapies. And the focus of this will really be centering on the pathogenesis, or basically the cause of NPC disease at the cellular level. So I think, as most of you are aware, NPC disease is caused by mutations either in NPC1 or NPC2 genes. The incidence, based upon work that Marie Gagne has done over the years, has shown it's roughly about 120,000 live births. I would just add as an editorial that I think this is likely an underestimate of the true incidence of NPC disease. I think we have a very difficult time in terms of achieving diagnosis, and therefore it's likely that it's much more frequent than we think. And hopefully, as we introduce new markers and new ways to do rapid diagnoses, we'll be able to get a true handle on the incidence of NPC disease. The major issue at the cell biological level is that there's cytotoxicity due to the accumulation of free cholesterol within the lysosomes. So what we see here really are a couple you see a couple of cells that are shown in the fields here. On the right, orange or reddish staining is actually NPC1 protein. And on the right here, you actually see blue staining, which is cholesterol. And what you see is that wherever there's orange staining, you don't see any of the blue staining. And where you see the blue staining, you don't see the orange, which basically means that free cholesterol is accumulating here because of the lack of NPC1 protein. And when you have the NPC1 protein, you don't accumulate the free cholesterol. So that is we think that's really the central etiology or cause of what leads to the pathogenic cascade of NPC disease. It's really this accumulation of cholesterol and lipids in the cell. This eventually leads to neuronal cell dysfunction and death, particularly in the Purkinje cells in the cerebellum. And I think, as most of us are well aware, that we have limited therapeutic options available in Europe and a number of other countries. We do have miglustat, which has been approved, but currently in the United States, we don't have any FDA-approved therapies for treatment of this disease. So in terms of the pathogenesis of the disease, I think it really begins with the dysfunction of the NPC1 protein. Mutations that accumulate in the NPC1 protein inactivate it. As a result of that inactivation, we end up with accumulation of lipids like cholesterol within the lysosomes of the cells. We know that roughly about the same time, concomitant with this, we see that you end up with what's considered a dysfunction of the lysosomal calcium homeostasis. This is work that has been done in Brian Platt's lab in the UK, and I think she's shown quite convincingly that calcium regulation in those organelles is not normal in the NPC cells, and probably plays a major role in terms of the pathogenesis. Ultimately, the biggest problem is the delivery of cholesterol from the lysosome out to the rest of the cell, and this is what I refer to as defective endocytic transport. The cholesterol just gets trapped within the lysosome and is unable to be utilized by other organs within the cell. Downstream of this is basically the oxidative stress and inflammation that is characteristic of the NPC in the NPC animals and also the NPC human subjects, where we see significant number of infiltrating inflammatory